Hello everyone. In this session, we are going to discuss about the 11th exercise of the DLT program manual. In this, we have to build the standard CNN architectures like LENet, AlexNet, VGG, others. So in this example, in this exercise, I'm going to deal with the LENet and VGG. That is enough for training. So we are handling the LENet and VGG16. So we have to build the model on the TensorFlow Keras, and we have to check the accuracy, and also we have to verify whether it is the overfit, underfit or perfect fit. And of course, we have the liberty to add the regularizers and dropout layers to handle the overfit. And the data set for this, we have, and one more thing, they have mentioned that for the satellite images. So we have to go with the satellite images. The original data set was taken from the Kaggle, and in the drive also we have given the data set. This data set is having the various images of the taken from the satellite. I think you may experience these from the Google Maps. See here, these are the river images, meaning that all these are having the rivers. In the Google Maps, you can observe that these are the rivers. See here, this is the river, this is the river, this is the river, like this. And the residential area is looking like this. See here, these are the residential areas. You can open the Google Maps now and you can see that you will get like this. And industrial can be represented like this. See here, this is the industrial area. And another thing is highways images are also there. Highway images, see here, this is the highway, this is the highway, this is the highway. You can observe that this is the highway, ring road. I think it is looking like the ring road, and this is also looking like the ring road exit point, like this. All these are the highway images. And another format also there is the forest images. See here, these are the forest images. See here, these are the forest. And then we are having one more annual crop. Crops are looking like this. These are the crops. You can identify the crops by using this. So this is the data set available. And actually this data set, in the original data set, there are two formats given. One is the TIF format and another one is the JPG format. And we are considering JPG format only because in this exercise, the main aim of this exercise is to verify the VGG16 and LENet only, not for the TIF images. So I am taking the JPG images. So these are the various varieties of the classes available. Now we have to load in the, as usual, the dataset loading is same. So we are importing the required libraries, and yeah, we have to connect with the GPU. Okay, manage the sessions and remove. Yeah, we are going with too many sessions. Yeah, there are no sessions. Now we can connect with this. Connect without GPU. I think my limit is over. No problem. We can train the models like this. So it is loading the libraries. Yeah, so it is loaded. Now I want to connect with the drive. The loading of images, it is as usual because it is organized in the proper directories. The directory name is the label name. So directly we can take the method straight away. So meaning that the directories, we have to provide the main directory, and then the image size is 32 by 32. Why we are going with the 32 by 32, that I will let you know. And I am loading this. Let us execute. In our regular way, we are going with the 32 by 32 images only. And actually what I have added is, here I am displaying in the loop I am displaying I, meaning the directory name. So we can understand that annual crop images are loading, forest is loading, and then some other images. One by one we will understand that which are loading now. So highway images are loaded, loading the highway images. Industrial images, and all these are loading step by step. And residential, I think one more is there. Okay, it is loaded. Yeah, river is getting loaded. After this, we have to check the images, the loaded images size. That is 500 images are there total for every category. This is also modified. Actually 3000 images are there for every category. So we scaled it to 500 images for each category. And shape 3000 images, 6 categories, 3001. One image may be different in one directory. Okay, so 32 by 32 by 3. And target, we have to set the target category codes as usual in the like our previous programs. And we are going with the train test set. Now we have to build the LENet file. For this I have given the references, 2 references I have given. Actually in the previous programs there is no limit to add the number of layers, but here we have the standard structures, that is LENet 5. LENet 5 means 5 major layers are there. So this is the standard architecture provided. This will work for most of the small scale images. So it is suitable for most of the small scale images. So what is this? Let us have a look on this, the architecture. It is in the Kaggle. We can open this. I have provided the Kaggle link. See here, in this there is a nice description. This is a standard format. Structure of LENet means this is our regular CNN only, but only the thing is how many layers we have to take, what is the size of the kernel, and how many units have to be taken for each layer. Everything is standardized. So see here, this is the image size. In the LENet 5, the image size is standard image size is 32 by 32. We have to take, and the first layer C1, we will call it as the C1. The first layer is having 6 filters, and 28 by 28 we have to take that as the 28 by 28. Actually 32 by 32 is the kernel size, so that the output is 28 by 28, and the kernel size is also fixed, that is the 5 by 5 kernel size we have to take. This is the first layer. And then average pooling, in general we are using the average pooling, that is the subsampling, and again convolution and subsampling, convolution, subsampling, and then we are going with the flattening and the dense layers. So the summary is given here. The first convolution is 5 feature maps, meaning that number of filters is 6, and we have to provide the 32 by 32 input, and 28 by 28 will be the output. 5 by 5 is the kernel size, and then the stride is 1, and the tan h, activation is tan h we have to take, and pooling layer also not max pooling, we have to take the average pooling here. Convolutional, see here, convolutional average pooling, convolutional average pooling. Here the 16 size is 16 here, the pooling, the number of kernels is 16, and then convolution of 120. Next convolution is 120 convolutions. meaning that 120 filters we have to take, and fully connected layer, that is the dense layer, with 84, fully connected with 10. Here they have taken 10 because they are working on the digit data set. This is depending upon our data set, meaning that number of outputs, depending upon the number of outputs categories. So the detailed description was given for the each and every layer. You can go through it, and in the another link was also provided. This is the very good tutorial for the LENet. So see here also they have given the layers step by step, and how to implement also they have given. In the Kaggle also they have given the implementation of the layer. So here this is the building of layer. So this is the filter, this is the input size is 28 by 28, and we have to go with this. Of course 32 by 32 also we can change little bit, but standard, if you want to go for the standard sizes, we have to go for the 28 by 28. And let us go with this building. Here I am taking the size, actually 32 by 32 we have taken, right? If you want you can change that. Again I can change it. See here 28 by 28, here we are calling 32 by 32 instead of that 28 comma 28, because the LENet is taking the 28 by 28. I am loading the images. So the images are loaded with the 28 by 28. So shape is 28 by 28 by 3, and again categories, we can convert the categories and try and test split. Now we can build the model. See here, I want to build the LENet 5. So architecture we have already seen. According to that, first layer is convolutional, conv2d of filters, 6 filters, and kernel size is 5 by 5, tan h as they mentioned in the architecture, and I am taking the 28 by 28 by 3 here. I am taking 28 by 28 by 1 is also acceptable, but 28 by 28 is the fixed size, and average pooling I am taking, and I am loading that. I am importing from the keras.layers average pooling 2D, and then the second layer is 16 filters, and kernel size is 5 by 5, tan h, and next convolution is 128, 5 by 5, tan h, and dense is also having the tan h activation, dense of 84 as mentioned in the architecture. You can go through this architecture and you can build the model. According to the architecture we have to build the model, that is only the thing. So see here, and then we are going with the final. See here in the given architecture they have used the 10, they have used 10 because in their data set 10 categories are there, but in our data set we have only 6 categories. So we have to go with 6 units in the last dense layer, and then we are going with the summary. If the summary is displayed, your model is built. Oh, there is some problem here. I think this is scaled with 3 by 3, because of that reason we are getting. So instead of that we can go back with the 32 by 32. Yeah, let us go back for the 32 by 32 image, because it is not getting the dimensions. You can observe that the dimensions are not matching. So we have to go back for the 32 by 32. I'm just re-executing the same pre-processing 32 comma 32. I'm resizing this. I'm just executing again. So with 32 by 32, I'm going with the 32 by 32. So we are getting this because conv2d5, by conv2d5 we are getting 1 by 1 directly. Because of that reason it is not going to go for 5 by 5 kernel. It cannot support the 5 by 5 kernel. See here. Okay, now we are going with this compilation. Compile the model and fit the model with the 20 epochs. I'm trying with 20 epochs. So it is getting trained slowly. If you get stuck somewhere like this, yeah, it is increasing. So you need not worry. Yeah. Actually, you can start the GPU here. And this, you can go for the accelerators. So change the runtime type. You can go with the runtime type. Here you have to select this. Actually, that is not started for me. So already I have executed number of programs, so it was stopped. So you can go for the GPU, so it will get trained fast. So here only 20 epochs I have run. So you can go with the 25 or 30 also, or 50 epochs or 100 epochs also, not an issue. And it is a 63 accuracy. It is 69 train accuracy, and test accuracy is 63. So it is acceptable, not an issue. Now I want to build the VGG16. For VGG16 also there is the standard architecture. We can go for the standard architecture of VGG16. So you can go through these links. Total 16 layers will be there. 16 convolutional layers will be there. Convolutional and fully connected layers will be there. See here, the input size will be the 124 by 124 by 3, and from there onwards there are several set of convolutional layers. See here, initially we will go with the 3 by 3 convolution with the 64 kernels, set of 2, and then we are going with the next set of convolutional. Pooling is also there in between. This is the convolution 1, 2 convolutions, again 3 convolutions, 3 convolutions, 3 convolutions, and then fully connected. There is a standard architecture for this. You can see that here, first convolution with 124 by 124, and the second convolution with 2 sets of convolutions, and then go with the 2 sets of convolutions with 128, 2 sets of convolutions with 256, 3 sets of convolutions with 512, 3 sets of convolutions with 512, and max pooling. They are using the max pooling, and in the VGG16, this is for complex images. We can go for the VGG16. It is little heavy model. Because of this reason, you should go for the GPU for training. Okay, you can start the GPU there and you can train that. So you can go through this tutorial for convolutional, that is the VGG16. They have given with the flower dataset. We are working on the satellite image datasets. So for that, I have to go for load the images with 224 by 224. We should go for loading the data set. I am calling the same method, but I am giving the 224 by 224. It may take some time to load the images and prepare the data set. And it is loaded. Now I can go for the train test data sets separately again. Again, I have to divide the train and test data sets. After separation of that, I am going to build the model. See here, 2 sets of convolutional layers and 1 max pool, and activation is ReLU, and kernel size is 3 by 3, clearly mentioned in the VGG16. So here convolutional 2D and max pooling. convolutional 2D with a three convolutional 2D sets, and then max pooling, three convolutional layers and max pooling, and again three convolutional with the 512, and then flattening, and then dense layer with 4096 and 4096. This was mentioned in the standard model only. I'm following all those standards, and then I'm building the model, and we have to change that to last layer. You have to concentrate on the last layer. We have six categories, so we are sticking on the six categories only, and then compile the model. And I'm executing this without GPU. I'm going to execute, so it will take a long time. So I just want to execute. I just want to show you how to execute. That's it. So see here, with GPU only you can execute this properly. Without GPU you cannot execute this. Okay. Now we can, after that we can evaluate with the test data set. So this is the way how you can execute this program, the lab level. I hope you understand and you can go through this and complete this exercise. Thank you.